So students, let us discuss Euler's theorem, the very easy concept and very scoring concept. Now, what is the statement of Euler's theorem? It says that if you have a function, if you have a homogeneous function f or u, which is a homogeneous function of degree n, means it can be expressed in the form of this, then x dou u by dou x plus plus y dou u by dou y is equal to nu. So this is the basic definition of Euler's theorem, right? So whenever there is a function, suppose if I am saying I am giving you a function u is equal to x cube plus y cube upon x plus y. Now I need to first convert it in this format. Okay, so for this, what is the concept? See, what is the highest degree of x here? 3. So take x cube out. So what is left? 1 plus y by x cube upon, in denominator highest power is 1. So 1 plus y by x. Right? So this is x square and function of y by x. So I have converted my given question u in this format. Now here n is equal to 2. This power is called n. So I can write by Euler's theorem x dou u by dou x plus j dou u by dou y, sorry not j, y, dou u by dou y is equal to n u. U means question itself. Right. So this is a direct question for Euler's theorem. We can easily prove the Euler's theorem. See how we will prove the Euler's theorem if u is equal to x to the power n function of y by x. Right. So what is dou u by dou x? So I will be doing the simple differentiation. Apply the product rule. So n x to the power n minus 1 function of y by x plus, now differentiation of this part. So f dash of y by x and minus y by x square. Correct? Now I have to multiply this by x. So x dou u by dou x is equal to n x to the power n function of y by x plus. Now here you observe I have x to the power n. So x to the power n and I am multiplying by x again. So plus 1 and here upon x square is there, so minus 2. Correct? And then minus y I have and then f dash y by x I have. Now x dou u by dou x is equal to n x to the power n function of y by x minus x to the power n minus 1 y f dash y by x. Let it be equation number 1. Now differentiate the same thing with respect to y. So what is dou u by dou y? It is equal to x. Now no need of product rule because x is constant. So f dash y by x and 1 by x. I need to multiply this by y. So y dou u by dou y is equal to x to the power n minus 1 y f dash of y by x. This is equation number 2. Now add equation number 1 and 2. What you will get? X dou u by dou x plus y dou u by dou y is equal to, now if you observe very carefully, this term and this term are same but opposite sign. So they will get cancelled. So n x to the power n f of y by x, which is n to n, and this is what? U. So nu. This is how you prove the Euler's theorem. Right? Now in this there is one more category where I will have this type of concept. I will not have a homogeneous function. I will convert it to a homogeneous function. Okay. Now let us do a simple question to make it more clear. Suppose you have u is equal to x plus y upon root x plus root y. And I am asking find the value of x dou u by dou x plus y dou u by dou y. Right. So what I will do, I will not differentiate it completely. I will apply the Euler's theorem. So for Euler's theorem, I need to convert it to my required format. So what is the highest degree of x here? 1. So take out x common. 1 plus y by x. Denominator, if you observe, it is x root x, that is x to the power 1 by 2. So 1 plus under root y by x. So my target is that here everything should be in terms of y by x. So now this is equal to x to the power 1 by 2 and function of y by x. I got my standard format. What is the value of n here? N is 1 by 2. Right? So my theorem says x dou u by dou x plus y dou u by dou y is equal to nu. So 1 by 2 u. U is what? X plus y upon root x plus root y. So I am done. Okay. Now what is a variety and other category I am telling? Suppose the same question if I write like this. Sine inverse x plus y upon root x plus root y. Then what? Right. So in this case, what you have to do? You have to write sine u is equal to x plus y upon root x plus root y. And this will be as we did upstairs here. Same way I will convert it to function of y by x. Okay. Now here I will apply the extension of Euler's theorem, which says that x dou u by dou x plus y dou u by dou y is equal to n f of u upon f dash u. Right. So this is the formula I'll be using. So see how you have to do the questions. First step, if this is a question, you convert it to this format. And now here you declare. Okay, here you will declare what is your value of n? N is 1 by 2. What is your fu? Fu is nothing but this function, that is sine u, and f dash u, which is equal to cos u. Now put in this formula. So x dou u by dou x plus y dou u by dou y is equal to 1 by 2 sine u upon cos u, which is equal to 1 by 2 tan u. So this is how you have to do the question. Right. So overall you can sum up that in Euler's theorem, I have two categories. One formula is x dou u by dou x plus y dou u by dou y is equal to nu when they are giving the homogeneous function. Other formula is x dou u by dou x plus y dou u by dou y is equal to n f of u upon f dash u. Correct? So these are the two formulas I will be using. Now let us quickly do 2-3 questions to make it more clear. Now the first question is, suppose u is equal to log of x to the power 4 plus y to the power 4 upon x plus y. Right? So what I will do, what is the opposite of log? Exponential. So e to the power u is equal to x to the power 4 plus y to the power 4 upon x plus y. So this will become x to the power 4 common 1 plus y by x to the power 4 upon x common 1 plus y by x. Okay, so this is x cube and function of y by x. Now in this case, n is equal to 3, f of u is equal to e to the power u and f dash u is equal to e to the power u. So what will be the answer? Answer will be x dou u by dou x plus y dou u by dou y is equal to n fu upon f dash u. So 3. So this is done. Now same question let me modify. If u is equal to e to the power x to the power 4 plus y to the power 4 upon x plus y. Then what you will do? What is opposite of e? Log. So log u is equal to x to the power 4 plus y to the power 4 upon x plus y. So I'll do x by x to the power. Again same thing I'll do. Cube function of y by x I'll get. Now in this particular question, my n is equal to 3. Fu is equal to log u. And f dash u is equal to 1 by u. So answer will be x dou u by dou x plus y dou u by dou y n fu upon this. So it will be 3u log. So that will be the value of this. Correct. Same question if I put like this. U is equal to cos inverse of x to the power 4 plus y to the power 4 upon x plus y. Then what you will do? Cos u is equal to x to the power 4 plus y to the power 4 upon x plus y, which is just now we did x cube function of y by x. So now in this question what you will write? N is equal to 3, f of u is equal to cos u, and f dash u is equal to minus sin u. Correct? So x dou u by dou x plus y dou u by dou y is equal to n fu upon f dash u. So minus 3 cot u. So this is how you have to do the questions. Okay, let me quickly explain you a few different questions. Now suppose you have this category. Wait, this one. If u is equal to tan inverse y square by x. Okay, then what you will do? See now, I will write tan u. Observe this question carefully. There is a little difference here. Y square upon x. Now there is no x terms in the numerator. So what I want to do, I don't want to write y only. As I told you, I want to create y by x function. So I will write it as y by x ka whole square. So basically I have divided it by x square. So I should multiply it by x square also. And denominator it is x. So this will become x y by x ka square. So this will become x function of y by x. So now your n value is equal to 1. Okay. And your fu is tan u. And your f dash u is equal to secant square u. So answer is x dou u by dou x plus y dou u by dou y n fu upon f dash u. This is nothing but sin u upon cos u and cos square u. Right? So x dou u by dou x is also written as ux, y uy is equal to sin u cos u. So I can write x ux plus y uy is equal to 1 by 2 sin 2u. Because I know that 2 sin u cos u is sin 2u. Just multiply and divide by 2 and you write this. So you can reduce like this. Though here only you got the answer. But this is only the way to reduce it, right? So same way, you can do this question also. Suppose u is equal to x upon y plus z plus y upon z plus x plus z upon x plus y. So u is equal to, see in the numerator, x you take common. Right? So here I am left with 1 plus 1 y plus z. X I have taken common. So here it will become like this. Now denominator also you take out x common because highest degree is x only. So y by x plus z by x. Here z by x plus 1. Here 1 plus y by x. So this is x to the power 0 function of y by x comma z by x. This is the extension for the variable. Okay. Now the same definition. Now since 3 variables, so x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to nu. N is what here? 0. So 0. So answer. Correct. Same way, if I write this, u is equal to 1 by x square plus 1 by xy plus log x minus log y upon x square plus y square. Your target is always to get y by x and z by x. Okay. Now here if I do this question, I can rewrite this first like this plus 1 by xy minus log of y by x because I want y by x. Okay. X square plus y square. Correct. I have just applied the log property. Now in the numerator what I can take common? Nothing. So x to the power 0 is common. Okay, and in denominator x square is the highest degree. So now numerator what is left? 1 plus 1 minus log of y by x. Here denominator x square gone, so 1. Here x square if it is gone, so y by x. Here 1 plus y by x ka square. Right? So u is equal to x to the power minus 2. Then function of y by x. See everywhere it is y by x only. So I can write like this. So n is equal to minus 2. So what is the answer? x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to nu. So minus 2u. Correct? So you can write it x ux plus y uy plus z uz plus 2u is equal to 0. Done. Correct? So questions are very simple. Only you have to convert it into the form and apply the basic definition. There are few questions where you may get stuck in differentiation. So please practice this type of question. X square plus y square minus z square upon x plus y minus z. Okay. So now what I'll do, secant u is equal to x square if I take common, or let me write first so that you should not get confused. Now what is common here? X square common, 1 plus y by x ka square minus z by x ka square upon x common, 1 plus y by x minus z by x. Correct? So secant u is equal to x function of y by x comma z by x. Now here n is equal to 1, fu is equal to secant u and f dash u is equal to secant u tan u. Right? So my answer will be x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to n. N means 1 into secant u upon secant u tan u, which is nothing but cot u. So done. So now like this you can try this question as well. U is equal to cosec inverse x to the power 1 by 2 plus y to the power 1 by 2 upon x to the power 1 by 3 plus y to the power 1 by 3 and whole power 1 by 2. Okay. Now see here, cosec u is equal to x to the power 1 by 2 plus y to the power 1 by 2, x to the power 1 by 3 plus y to the power 1 by 3 and 1 by 2. So what is common from numerator? X to the power 1 by 2 common, but whole has a power 1 by 2. Denominator x to the power 1 by 3, 1 by 2. And here you will be left with 1 plus y by x power 1 by 2. Okay, on 1 plus y by x to the power 1 by 3 and the whole to the power also 1 by 2. Correct? Whole to the power also 1 by 2. Now what is left? Cosec u is equal to x to the power 1 by 4 minus 1 by 6 function of y by x. So x to the power 6 minus 4 is 2, 2 by 24, that is 1 by 12 function of y by u. So what will be the answer here? N is equal to 1 by 12. So answer will be x dou u by dou x plus y dou u by dou y 1 by 12 u. Fu, right? Fu is equal to what? Cosec u. And f dash u, that is, you can differentiate cosec u and here you write fu value and f dash value. Right? So the only thing is finding out the n and differentiating. This is all about the Eulers theorem. Thank you.